You are given 8 identical looking balls. One of them is heavier than the rest of the 7. All the others weigh exactly the same. You are provided with a simple mechanical balance and you are restricted to only 2 uses. Can you find the heavier ball? Let me repeat the puzzle. You are given 8 identical looking balls. One of them is heavier than the rest of the 7. All the others weigh exactly the same. You are provided with a simple mechanical balance and you are restricted to only 2 uses. Can you find the heavier ball by using only 2 uses of the mechanical balance? Let me explain the solution now. For convenience sake, let's name the balls 1 to 8. First, we weigh 1, 2, 3 on the left and 4, 5, 6 on the right. This is the first measurement. There are 3 scenarios which can arise from this. Let's consider the scenario 1. If the left side is heavier, then we know that one of 1, 2 or 3 is the heavier ball. Now in the second measurement, weigh 1 on the left and 2 on the right. We will know if 1 or 2 is heavier. If they balance out, then 3 is the heavier one. Thus, heavier ball is identified by exactly 2 measurements in this scenario. Let's consider the scenario 2. If the right side is heavier, then we know that either 4, 5 or 6 is the heavier ball. Now in the second measurement, weigh 4 on the left and 5 on the right. By doing this, we will know if 4 or 5 is heavier. If they balance out, then 6 is the heavier one. Thus, heavier ball is identified by exactly 2 measurements in the scenario 2. Let's consider the final scenario, that is scenario 3. If 1, 2, 3 and 4, 5, 6 balance out, then we know either 7 or 8 is the heavier one. Weigh both of them to find out which one is heavier. Again here, heavier ball is identified by exactly 2 measurements. Let me summarize. The first step is determining which set of 3 balls contains the heavier one. So choose balls 1, 2, 3 and balls 4, 5, 6 and weigh them. If one set is heavier, save those 3 balls. Pick 2 balls and place for measurement. By doing this, we will know which one is heavier. If they balance out, then other is the heavier one. If neither side is heavier in the first step, proceed with balls 7 and 8. In the final weighing, weigh both of them to find out which one is heavier. By following these simple steps, we can find which ball is heavier in just 2 measurements. Your room has 3 switches. One of these switches is for a fan in the next room. You cannot see whether the fan is on or off unless you come out of the room. What is the minimum number of times you may go in a room to identify the correct switch in another room? Let me explain the solution now. I would go only once to the other room to find out the accurate switch for the fan. Here is the step-by-step explanation. I would turn on the first switch and keep it on for 2 to 3 minutes. Next, I would turn off the first switch and turn on the second one. I would run to the other room as soon as I switched on the second switch. Here, there are 3 possibilities. If the fan is running, the second switch is for the fan. If the fan is not running, obviously, second switch is not the right switch. If the blades are rotating slowly, the first switch corresponds to the fan. It's because fan will not immediately stop when the switch is turned off. Speed will reduce gradually and finally come to stationary, and for this it takes time. If fan is not running and it is not rotating slowly, that is, if the fan is in stationary, then the correct switch of the fan is the third one. Thus, minimum number of times you may go in a room to identify the correct switch in another room is just 1. You are on your way to visit your grandma who lives at the end of the valley. It's her anniversary and you want to give her the cakes you have made. Between your house and her house, you have to cross 5 bridges, and as it goes in the land of make believe, there is a troll under every bridge. Each troll quite rightly insists that you pay a troll toll. Before you can cross their bridge, you have to give them half of the cakes you are carrying, but as they are kind trolls, they each give you back a single cake. How many cakes do you have to leave home with to make sure that you arrive at grandma's with exactly 2 cakes? Let me repeat the puzzle. You are on your way to visit your grandma who lives at the end of the valley. It's her anniversary and you want to give her the cakes you have made. Between your house and her house, you have to cross 5 bridges, and as it goes in the land of make believe, there is a troll under every bridge. Before you can cross their bridge, you have to give them half of the cakes you are carrying, but as they are kind trolls, they each give you back a single cake. How many cakes do you have to leave home with to make sure that you arrive at grandma's with exactly 2 cakes? Answer to this puzzle is 2 cakes. At each toll bridge, you are required to give half of your cakes and you receive one back, which leaves you with 2 cakes after every bridge. Let's analyze the solution. In the first toll, you give 1 cake to troll because we are assuming that you started journey with 2 cakes and in each toll, you have to give half of the cakes. In this case, it is 1. In return, you receive 1 cake back, hence there is no loss to you. You started with 2 cakes. After first toll, you still having 2 cakes and this will repeat in all remaining tolls. So if you start with 2 cakes, you will end up with 2 cakes after the last toll. Thus answer to this puzzle is 2. This is a very simple scenario. What if the question is asked in such a way that there are only 3 bridges and how many cakes do you have to leave home with to make sure that you arrive at grandma's with exactly 3 cakes? This requires generalized solution. Let's assume you are carrying x cakes. Since you have to give half of the cakes you are carrying and each give you back a single cake, the number of cakes after first bridge is x divided by 2 plus 1, and after solving this equation becomes x plus 2 divided by 2. After second bridge, number of cakes left is x plus 2 divided by 2 whole divided by 2 plus 1. After solving this equation becomes x plus 6 divided by 4. So after third bridge, number of cakes left is x plus 6 divided by 4, which is actually the total number of cakes remaining after the second toll, divided by 2 plus 1. After solving, equation becomes x plus 14 divided by 8. And we know that the number of cakes left after third bridge is 3. Solve this equation for 3. After solving, we get the x value is equal to 10. So thus, if there are only 3 bridges and number of cakes you have to leave home with to make sure that you arrive at grandma's with exactly 3 cakes is 10 cakes. This is generalized solution. You can use this technique for any number of cakes. Suppose you have a regular hexagon made up of matchsticks with 3 diagonals in it. The task is to convert the given hexagon into 3 equilateral triangles by moving only 4 matchsticks. Before actually getting into the problem, let me explain what are hexagon and equilateral triangle. A hexagon is a 6-sided 2-dimensional geometrical figure. The total of the internal angles of any hexagon is 720 degree. A regular hexagon has 6 rotational symmetries and 6 reflection symmetries. All internal angles are 120 degrees. An equilateral triangle is a triangle in which all 3 sides and angles are equal. All 3 internal angles of equilateral triangle measure 60 degree. Let's get into the puzzle now. Here is a regular hexagon made up of matchsticks with 3 diagonals in it. The task is to convert the given hexagon into 3 equilateral triangles by moving only 4 matchsticks. Let me explain the solution now. Solution can be achieved by moving 2, 4, 5, 6 numbered matches to get exactly 3 equilateral triangles. First move matchstick 4 adjacent to matchstick 7. Next move matchstick 6 adjacent to matchstick 8. Next move matchstick 5 and connect to matchstick 6 and it forms the base for the part of the triangle 3. Finally move matchstick 2 and connect to matchstick 4 and 5 which forms the complete base for the triangle 3. Now we can clearly see that there are 3 equilateral triangles. 2 triangles are formed with side equals single matchstick, whereas third triangle formed with sides 2 matchsticks. There are 2 candles of equal length and of different thickness. The thicker one lasts of 6 hours, the thinner 2 hours lesser than the thicker one. Ramesh lights the 2 candles at the same time. When he went to bed, he saw the thicker one is twice the length of the thinner one. How long ago did Ramesh light the 2 candles? It is given that thicker one lasts 6 hours, so after each hour, 1 by 6 of the candle is melted. Thinner one lasts 2 hours lesser than thicker one, that is, it lasts 4 hours. So after each hour, 1 by 4th of the candle is melted. Logically, after 1 hour, remaining portion of the thicker candle is 5 by 6 and remaining portion of thinner candle is 3 by 4. After 2 hours, remaining portion of the thicker candle is 4 by 6 and remaining portion of thinner candle is 2 by 4. And after 3 hours, remaining portion of thicker candle is 3 by 6 and remaining portion of thinner candle is 1 by 4. Here we can notice that after 3 hours, the remaining portion of the thicker candle is 3 by 6, which is 0.5 or half. Remaining portion of thinner candle is 1 by 4, which is 0.25 or quarter, which is basically the thicker one is twice the length of the thinner one. Therefore, the answer is 3 hours.